Okay, so in today video we will discuss about the doubly linked list. Okay, first of all we saw previously like what is a singly linked list and how it works. Okay, and today we will see what is a doubly linked list, how it works, etc. So one of the problem that we can see in the singly linked list is like for example, suppose this is the linked list we have where head is pointing to the very first node and then next node of the B is present pointing towards the C and C pointing towards the D. So we are able to traverse because the node B, B is an object. For example, inside that there are two things. One is a data, another one is a next. So data will be holding the actual value and the next of the object will be pointing towards the next object, means it will be holding the address of next object. For example, the next property of B object is holding the address 3000, which is the address of C object, and hence we can say it is pointing towards the C object. And then this is actually happening for the every object, means if we are at the head knows what is the address of the first element, that is 2000. So here we can go to the object B because head is knowing, head is having the address of B object. Likewise, B object has a next property, next variable we can say, which is holding the address of a C object, and hence from B object we can traverse to C object, and from C object we can traverse to D object. This is one way traversal. But there is a problem with the singly linked list, and the problem is if we have to traverse in reverse direction, then how we can proceed? Because if we are on the head, then we know head is pointing towards the object whose address is 2000, and hence we can go towards the B object. Likewise, B has a next property which is holding the address of next object, that is 3000, and 3000 is the address of a C object. Hence from B object we can go to C object, and likewise we can go from C object to D object because next property of C object is holding the address of next object, means we can move in one direction. But if suppose for example we are on D object and we have to go back to the C object, so how can we travel? Because on D object, if you see, we have data and we have next. So data is holding the value, and next basically will be holding the address of the next object. But there is no way where we hold the address of the previous object, and that is the problem, that we will not be able to traverse, we will not be able to go back to the previous object. Okay, so if we are on the D object, since from D object we are not storing the address of a C object, and hence in reverse direction we can't traverse in a singly linked list. Okay, so if we have a requirement to traverse in the reverse direction, then we will need the doubly linked list. Okay, so basically there is minimal difference between singly and doubly, that in the doubly linked list, along with holding the address of next node, there will be one more property which will be holding the address of the previous node. That's it. We are going to add one more property in every node, that will be the previous node we can say, and in that we will be holding the address of previous object, so that we can travel in reverse direction also. So basically this is what we have today. So today we will be discussing about the implementation of doubly linked list, like how doubly linked list works and how we can have our own implementation for doubly linked list. So this is what basically we have. Let's go and discuss this. So first of all I will try to draw the diagram also so we can understand. So here what will happen, we are just creating the object of doubly linked list, and if you see inside this, so these are basically we have the properties for doubly linked list class, and inside that when we will create the object, typically there are few methods and then one variable I will say. So whenever object gets created, this variable will get created inside this object doubly linked list. So I can draw something like this. this will be one object, okay, that basically will be created from here. Okay, we are creating the object, so in this object whatever the global variable we have, that will be allocated in that object. Okay, so something like this, in the heap area one object will be created, and definitely they will have some memory address. So let's assume basically the address will be assigned by operating system, but here as of now let's take some random address, maybe 1000. So assume 1000 is the address of this linked list, doubly linked list object, and inside that if we see, like in this we have one global variable called head, which is of non-primitive type node. So of course if it is a non-primitive, it means head will have the default value as null. Okay, so here inside this we can have one variable called head, and then the value null, by default null will be assigned into this. This is what basically will happen when this line will execute, and we know when the object will get created it will return their address, or we can also say कि basically this object will be created inside the heap, and that object will be pointed by this reference variable. So whatever the address this particular object will have, that their address will be stored inside this reference variable called obj. So something like this I can say, there will be one reference variable obj, and inside that 1000 memory address will be stored. Or we can also say this one will be holding the address of this object. Okay, so let's give the name of this object as a object. This is for our simplicity purpose. We can say this object as a object because this is basically actual the object of this doubly linked list. So I can also name it maybe doubly linked list. These are name only, doubly linked list. Okay, just for our understanding purpose. Okay, in memory when it will be created, it will basically have only address, nothing else, and then reference variable which will be pointing to this object. So this is what basically will happen when this line will execute. After that, on this object only there is one method called add. So this add method will be executing with value 7. Okay, so let's go and check like how it will execute. Simply I will put my breakpoint here, and then I will expand this. Let's see how record will be added in the doubly linked list. Okay, how we can traverse, etc. So in order to run it, simply I will run this code. Our breakpoint will hit it. It came here, then I will say F11. It should come. Okay, so now the value that we want to add in that one is, if I hover, the value is 7. Okay, so here is the object that we are creating, the object of node. And if you remember in the diagram I explained, like in simply linked list we had data and a next, and the problem was if we have to traverse in reverse direction, then we had no variable which will be holding the address of previous node. And so now in the node variable, in the node object we have increase one variable. So if you see, basically we are assigning the address, a new value of data, and then we have next as well as we have a previous also, so that this variable will be holding the address of previous object, so that if we want to traverse in the reverse direction, we can do with the help of this reference variable. Okay, so as of now, again one object will be created. We know when constructor gets executed, one object gets created in heap memory. So here this object will be created something like this, any random we can say, and then it will have three part. I will say uh, this will be previous, then data, and then next. Okay, then let's assume definitely they will have some address also. So 2000, and let's name also, so we can say this is the b object. Okay, and then if we see here, so basically data will be assigned, so data is 7, so data will be assigned to 7 here. So we can say data equal to 7. And then the other two, since other two we are not initializing, so next will remain in their default state, as well as previous variable will also remain in their default state. If you see, previous has value null, likewise next also has value null. So we can say this one is the previous one with value null. I can say null here, and then next will also have value null. So this is what basically will happen. Okay, and once it is done, then we know when object gets created, then it will have some address, and that address will be stored inside the node reference variable. And since this variable is getting created inside the method, so it will be a local variable. So one local variable will be created. I will say node equal to 2000, and this one will be holding the address of b object. So now it will be pointing towards the B object, something like this, because node is holding the address of B object. Then if this dot head, this basically is pointing to the current object. So current object is nothing but this class link doubly linked list. So head variable present inside this is whether equal to null or not. If we see in our diagram, so it is null. Here it represent currently it is null. So basically condition will be true, and hence control will execute this part. So it will go inside this, and here what we are doing, whatever the address we have inside the node reference variable, that address we are assigning to head reference variable. Okay, so in our example, if you see, so node reference variable currently is holding the address of 2000. So this 2000 will be assigned to this head. Okay, so the value of head will be overwritten, and the new value will be 2000. So here the head will have the value 2000, which is nothing, but this one will be happening because of this. As we know, कि node was holding the address of 2000, and that 2000 we are assigning to head. Okay, so this is what basically will happen. And to be honest, this head variable, reference variable, I can say, will start pointing to B object, because this head reference variable also holding the address of B object only. So diagrammatically, I can say something like this. So at this point of time, there will be two reference variable which will be pointing to B object, node as well as a head. Okay, so this is what basically happened. And since if block was executed, else part will be escaped. Okay, and then here the message will be printed like this: 0 was nothing but 7 inserted into the doubly linked list. That's it, and control came here. So if you see, it is showing 7 inserted into the doubly linked list. Likewise, let's go further and add 34. So this time again, but again one more thing, since last time when this got completed, once the method get completed their execution, all the locally created variable will be wiped out from the stack. So this node was created locally, and hence it will be erased once method gets completed. So last time for the 7, this one was completed, hence this node would have wiped out. Okay, so I forgot this. You have to assume something like this. Yep. So this got wiped out. Now again this method will be loaded into the stack. Data will be 34, and then again we are creating the object. So new node data, and the value of data is 34. Again this constructor will be executing, means one more object of node type will be created. So I can draw something like this. Okay, and okay, I can say control z. I will try to draw a, yep, and then this will again have three part. Yep, and let's have some address also. So assume it will have 3000 and the name of the object will be C. Why it is called doubly linked list? Because we can go forward as well as backward. So again, if you see in here, then we have data, and when this constructor will execute, the value of data, that is 34, will be initialized to data, that is in here we will have the data which will be holding the value 34. So data will be 34, and then the other two variable, that is next and previous, will remain in their default value, because we are not initializing the value of next and previous, just declaring. In that case, compiler will assign their default value, and the default value of the non-primitive data type is null only. So when I hover on previous as well as on next, you see it is showing null. Okay, so we will have the variable previous equal to null, as well as here we will have next, and the value of next also will be null. That's it, and we are done by creation of this object. And the object creation, or I can say the constructor call, takes place on this. So when constructor gets called, object gets created, and once object gets created, they will have some address. Again, that address will be stored to this reference variable node, which is again a local variable. So it will hold the address of newly created object, that is nothing but 3000. So we can say this is a node equal to 3000, and since node has the address of C object, so I can draw diagram something like this. Means since node is holding the address of C object, we can say this node reference variable is pointing to C object. That's it. And then again it will check if this dot head, this will be pointing to the current object, or you can say current class, means doubly linked list. Okay, so the head variable present in the current class, that is linked list, is null. Let's go and check the head variable present in doubly linked list. If you see here, so in doubly linked list, this time it is not null, it is holding some address, we can say. So this condition will be false, and control will jump to else block. And now here what we are doing, we are creating the object, I mean not object, but whatever the address we have in the head reference variable, same value we are assigning to a temporary variable called temp. And again, this is a local variable, because we are creating this inside this method, and all the variable that is created within a method is called local variable. So one temp variable will be created, and whatever the value we have inside the head, that will assign to temp. So I can say there will be one temp variable, and in this whatever the value we have in the head, if you see we have 2000. Okay, so it will, temp will have the address of 2000, because head is holding the address of 2000 in our example, and so temp will also have 2000, because we are assigning the value of head to temp. Okay, so here something like this will happen, and if I draw diagrammatically, I can say temp is pointing to B object. Then here temp will start pointing to this object, I can say. Next we have is, now we are traversing while temp dot next is not equal to null. So temp dot next, currently temp is pointing to B object, and the next variable present in B object is null or not. You see, the next variable is this one which is present in B object. Okay, so B object temp is currently pointing to B object. Okay, and inside B object there is a next reference variable which is holding null. Okay, so here we are saying ki, hey, whatever this temp is pointing towards, please go on that object, and on that object check whether next property is having null or not. Okay, so temp currently in our example is pointing to B object, and the next variable present in the B object is null. Okay, so this expression will be evaluated to null. Now condition is null is not equal to null. condition will be false, because null is equal to null. It's not like null is not equal to null. So this condition will be false. Control will jump to here. Okay, so it will come here, and now see what we are doing. So whatever the value we have inside the node reference variable, that is nothing but, I can say, 3000. Currently if you see, node is holding the address of 3000. So that 3000 will be assigned to next. Who's next? We have several next, right? We have next in C object also, and we have next in B object also. So who's next? The next which is being pointed by the next of the object, which is being pointed by temp reference variable. And if you see, temp is currently pointing towards the B object. Okay, so means next variable of B object. Okay, so next variable of B object will have the address value which is in node. Okay, so inside node we have 3000. The same value will be assigned to this one. So null will be overwritten, and the new value will be 3000. That's it. And then it represents this next has started pointing towards the C, because now at this point of time, node is also having the address of a C object, and the next is also having the address of C. So we can draw something like this, where this next is also pointing towards the C object. And then on the next line, what we are doing, again we are doing the assignment. That is, whatever we have inside the temp reference variable, that address we want to assign to previous reference variable. And previous reference variable to which object? The object which is being pointed by node, right? So currently if you see, it will not be the in the node. So currently node is basically pointing towards the 3000, right? Or C object we can say. So previous variable of which object? The object which is being pointed by node. Now obvious question is, node is pointing to which object? You see here, node is pointing to C object. It means the C object of means the previous variable of C object. So previous variable of C object should have temp. So let's go and check. Temp is having what value? So temp is having a 2000, and this 2000 should be assigned to previous variable of C object. Okay, so this null will be overwritten by the new value, and the new value will be whatever we have inside the temp, that is 2000. It will also have the same value. And to be precise, we can say this previous reference variable now is holding the address of B object. Okay, so we can draw diagram like this. This is our B object, right? So it will be in a reverse direction. Okay, so if you see, little bit, it seems like we are going and we are storing the address of both next as well as previous, right? If we are on C object and if we want to go back, so there we will have the address of previous object in the previous reference variable, right? So with this reference variable we can go back, and this is the reference variable which will be helping us to traverse in reverse direction. That is the purpose, guys, that we have included previous in the our node. So that's it. And then it will print the message that 34 was inserted. And again, when here represent ki our method call was completed, and once the method gets completed, it will be unloaded from a stack. But also, since it will be unloaded, you know during the time of unload, basically all the local variable that was created within this method, that will be removed. So this is the reference variable that was created, and another one was temp. Okay, of course this one was also, but in our diagram we didn't mention that. Okay, so that's why this data is in object, this is not in local variable. Okay, so this one will be the local variable, so this one automatically will be wiped out along with this node and temp. So we will also delete this variable like node, this was created in the stack locally, so this one will be wiped out. Okay, along with that we also had the temp reference variable, and so this one also will be wiped out. That's it. So this is what our diagram will look like when our two element will be added in the doubly linked list. Now let's go and check for the third one. So I will stop, I will put breakpoint here, and then I will run. Let me run it again. Yep, it came here. Again, as usual, the same thing will happen, like data will have the value 19, one object will be created, something like this. So at this time, I can directly create the object, maybe here. Okay, and then it will also have the previous, it will have some data, it will have some next. So let's assume it has some address, maybe 4000, we can say, and then the name of the object, we can say d object. Okay, and as usual, previous will have value null along with next, which is also set to null, and then there will be the data. So data will be initialized to 34 that currently we are passing. Okay, this is what basically happened when this line will execute, and once the object gets created, then their address will stored inside the node. So again, one more time, node variable will be created and they will have the address of 4000. Okay, so here this node will be pointing towards the D object, and this node one will be created inside the stack. That's it. Then again it will check whether head is null. So you can see head is still not null. Okay, so this condition will be false. Control will go inside the else block. Then we have a node. So one temporary variable will be created, and inside that, whatever we have inside the head, basically this we are doing for the traversal purpose. So whatever we have inside the head, that is nothing but 2000. So this 2000 will be assigned to this temp. Okay, so here one local variable will be created, and inside there will be 2000, that is whatever we have inside the head, same value assigned here, and then it will start pointing towards the b object, because temp also have the address of 2000 only, that is b object only. So we can say temp will also be pointing towards the b object. Now control will go inside the while. So here temp dot next, the next variable of the object which is being pointed by temp reference variable. So currently temp, you can see temp is pointing towards the b object, means the next variable of b object, we are checking whether it is null or not. So if you see the next of b object at this point of time, definitely it is not null. So something which is not null is not equal to null. Condition became true. This time it will come inside this, and then see what we are doing. So whatever we have inside the next variable of which object, guys, this is very important to understand. Like what exactly is this? What does it mean? So whatever the address we have inside the next, that we are assigning to temp. But obvious question is, next of which object? We have a lot of objects, we have a b object, c, d, and all of them has the next. So how will you identify which next it is talking about? So basically the next of the one which is being pointed by temp reference variable, and currently temp is pointing towards the b object, means next of b object. So if you see, the next of b object is holding 3000. So as per our example, this expression will be evaluated to 3000, and that address will be assigned to this temp reference variable, means this value will be overridden, and then this one will be overridden with the new value, that is nothing but 3000, we can say. And of course, since the address of temp got changed, so this arrow is no longer valid. This arrow, to be honest, this one will start pointing towards the next object, that is C object. Okay, because at this point of time, temp is holding the address of C object. So temp started pointing towards the C object, then control again will go to while, and now temp dot next is not equal to null. Which null, which next, right? So again read the same way, next variable of the object which is currently being pointed by temp. Let's go in our diagram and check temp currently is pointing to which object. If you see, temp is pointing to C object. Obviously, it means next variable of C object. So do you see? Do you think next of C object is null? Yes, this time it is null, and so this expression will be evaluated to null. So null is not equal to null. Condition became false. Control will jump out of the while loop, and here it will come. So you see what we are doing, whatever the address we have inside the node, that address we are assigning to next. Which next? The next which is being pointed by temp reference variable. So temp currently is pointing to C object. Okay, so next of C object, next of C object will hold the address which is present inside the node. So node currently is holding the address of 4000, and this 4000 will assign to next of which object? C object. Why C object only? Because this temp reference variable currently is pointing towards the C object. Okay, so whatever we have inside the node, that value will be assigned to next of C object, which is not nothing but this one. So the value will be overridden, and 4000 will assign to this next. Diagrammatically we can say this next will be pointing to this object. Okay, or I can draw something like this. So this object. Okay, that's it. And then on the next line, what we are saying, ki node dot previous means whatever the address we have in the temp reference variable, that address we want to store inside the previous reference variable. So inside the temp, if you see, we have 3000, and this 3000 should assign to previous reference variable, but previous of which object, that you will identify with reference variable. So currently if you see, node is pointing to which object? D object. Okay, so D object, previous variable of D object. Okay, this means previous variable of D object should have address present inside the temp. Whatever temp is having the address, same address should be available in the previous reference variable of which object? D object. Okay, so in here, basically, if you see, temp is having the address 3000, and this 3000 will assign to previous of D. So I will erase this value, and here now you see whatever we have inside the temp, that value will be assigned here, that is 3000. So we can say to whose address is 3000? C object. Okay, you see here we have C. So basically this previous will be pointing to C object, we can say. Okay, so this is the diagram we have, and then we are done. So it will go back, and now this method has completed their execution, so it will be unloaded from a stack. Hence all the local reference variable that was created, or any local variable those were created, they will be wiped out. So this temp and node was the local reference variable, because you see here is the node that we are creating, and here is the temp that we were creating. Okay, so these two will be wiped out. Okay, so from here let's erase that, so our linked list will look like little easier. and simpler. So likewise, this one will also be deleted. Yep. And this is what we have our diagram. Okay, so this way basically it will work. Okay, now if you see on every node wherever you are, we just have added the previous reference variable. And for example, now you are on D object, just assume, and you want to go on the back object. What means whatever the previous was there. So on D object, simply you have to check what is the address that is present inside the previous reference variable, and whatever the address it is, you just need to go on that address, which is nothing but C object. So this way you will come back. Okay, and we are done with this. Then we have display here. Let's go and check how display method works. This is similar like we had in our singly linked list. Okay, so if you see here what we are doing, just we are creating one local reference variable. This dot head means one local variable temp will be created, and it will be holding the address of a head. Whatever the value present in the head, same value will be assigned to temp. So one more local variable will be created here, anything you can assume, and whatever we have inside the head, same address will assign to here also, that is 2000. It means this one will start pointing to B object. Okay, and then it will go next. Temp is equal to null. Currently you see no, temp is having some address, it is definitely not equal to null. Condition will be false. This condition is written just to check whether linked list is empty or not. Okay, then this while loop is written for traversal. Currently we will traverse in one direction, that is first node to last node, and then we will discuss about reverse display. So in here, temp is not equal to null. Yes, this condition became true because temp is holding some address. Okay, it will go inside the while. Here it will print the data, means data of which object, the object which is being pointed by temp reference variable. Currently temp is pointing to the B object, so in B object check what is the value present inside the data. So in B object there is a data having the value 7. Okay, so it one will print 7. If I hover, you can see the value 7 will be printed with some space. Okay, so this 7 we can see here, 7 has been printed as the first element like this. So currently temp is pointing to B object, and hence data in B object is 7. Now you can guess what might be happening here. So temp dot next. Okay, so temp dot next will do what? Ki next variable, whatever the value present in the next variable of which object, the object which is being pointed by this reference variable, temp is currently pointing towards the B object. So next of B object, if you see, the next of B object is having address 3000. Okay, so means this expression currently in our example will be evaluated to 3000, and this 3000 will be assigned to temp. Okay, so temp will have now 3000. Okay, so the new value of temp will be 3000. So here, and then this temp we know is no longer pointing towards the B object, because temp now is holding the address of 3000. So if I draw the diagram, I can say temp has started pointing to C object, because the address which is present in the temp reference variable is 3000, and 3000 is nothing but is having the address of C object. Okay, so temp will be pointing towards the C object. Okay, and now it will again go, and here it will check whether temp is not equal to null. Okay, in our example if you see, so temp, do you think temp is null? No, temp is not equal to null. Temp is having some address that is 3000. So this condition will again be true. Okay, and it will come inside this. Then temp dot data. So data present in the object which is being pointed by temp. So currently temp is pointing to C object, and in C object whatever the value we have in the data, that will be presented. So here in the data we have 34. If we hover the value, you see here also we are getting 34. Okay, so it will print 34. And then okay, so I will run it again. It gives some issues. Let's run it again. We'll say this. I will go quickly till okay here. So yeah, data is 34, and then on here what it does, temp dot next, basically again the same, means whatever we have in the next assign it to temp. But which next? The one which is being pointed by temp. Temp is currently pointing to C object, means the next of C object is having 4000. Okay, so this expression evaluated to 4000, and this 4000 will assign to temp. Okay, so now this value of temp will have the new value, that is nothing but 4000. This way we traverse, and of course this arrow is no longer valid. In fact, this temp has started pointing to the object whose address is 4000, that is nothing but D. The means we can say कि D object, or we can say the address object whose address is 4000. Okay, now it will again go to the while block, and here temp is not equal to null. If you see, yes, temp had some address, it is not null yet, right? So it will come inside the while block. Okay, and again it will print the value. So whose value, whose data? The currently temp is now pointing towards the D object. Okay, so data of D object is having nothing but 34. Okay, so this 34 will be printed here. If I hover my mouse, you can see it is pointing 19. Okay, because in here the value was 90, right? Okay, so we took it differently. The first object was 7, then 34, then 19, and here we took in the different, oh, it was 19 only, it was my mistake, let's make it 19. Yep, here it was 19 because third element we added was 19 only. Okay, so it will print the 19, and then it will go here again, temp dot next, means next value, next whatever the address present in the next of temp object. So temp is pointing to D object, means next of D object. If you see, it is null, so that null will assign to temp because we are assigning to temp here. Okay, so this time the 4000 will be replaced with null. Here we will have the value null, and now you might have understood that this arrow is no longer valid. Okay, and the value present inside the, or you can say address is present, is nothing. Null means nothing, it is not pointing towards any object now. Okay, so control will again go to while, and this time temp is null. Null is not equal to null, condition became false because null is equal to null. It's not like null is not equal to null, right? So temp is null and is not equal to null, condition became false, and by that time all the value is printed. You see 7, 34, 19 has been printed. Then console right line, it will just change the line to, so currently you see cursor is pointing here, right, this blinker, and when this line will execute, automatically control will come to next line. Okay, it disappeared in my case. Okay, but this one is console right line is used to change the line. Okay, it will just go to the new line. Okay, so that's it. So this is how basically the display method works. Okay, and this is how basically we are able to display the masses in our doubly linked list. In our next video we will see how reverse display will work, and we will also see if we have to delete the node at a specified position, then what logic we can write. So currently this is what basically we wanted to discuss, and that's it. Thank you for watching. Yep, thank you.